In this lesson, we are looking at ionic compounds, chemical formulas, and naming. You will need your periodic table to complete the notes. Overall, an ionic compound is neutral. So for ionic compounds, the total ion charge is 0. This means that the total positive ion charge must equal or cancel out the total negative ion charge. Ionic compounds are found by combining positive and negative ions. You will learn to name and to write chemical formulas for ionic compounds. First, we will look at naming. There are different types of ionic compounds, and the naming works slightly differently for each type. We will look at the simplest type first. This is binary ionic compounds. This is the simplest type of ionic compounds and contains two types of monatomic ions. That means ions that only have one charged atom. Whenever you're naming ionic compounds, the metal goes first and the non-metal second. Remember that an ionic compound is made up of a metal and a non-metal. So the metal first, the non-metal second. And then we change the second element to end in I, D, E. The first one we just leave alone, but the second one we change. So for example, if we had calcium and chlorine, we would name it calcium, and then chlorine would change to chloride. Magnesium and oxygen would become magnesium oxide. As an exercise, we're going to look at naming the following compounds. Nickel and iodine will become nickel iodide. Sodium and chlorine becomes sodium chloride. Pause the video here and try the rest of these on your own. To check your work, you should get zinc sulfide, followed by potassium oxide, beryllium bromide, lithium phosphide, and hafnium nitride. Now that we've looked at naming, we're going to look at writing chemical formula. The combining capacity, or oxidation number of an element, is a number that represents the ability of an element to combine with another. So it's a number that represents the ability of an element to combine with another. For example, if you look at your periodic table, and I'm going to pull one up here, but this one doesn't have the charges on it. Yours will have the charges, and if you looked at calcium, and you look on yours, all these elements in the far left column, the alkali metals, they all have one electron in their outer shell. Next row over has 2. So calcium would have an ion charge of 2. That means a combining capacity of 2. It's 2 plus. So calcium has a combining capacity of 2 plus. It becomes Ca2 plus. And if you look at chlorine, it has a combining capacity of 1 negative. We're going to look at the steps that are needed to determine the chemical formula of a binary ionic compound. Sometimes this is called the swap and drop rule or the cross and drop rule. The first thing to do is to write the element with the combining capacity. So we said that calcium had a combining capacity of 2 plus and chlorine was 1 negative. Then we want to swap the charges and drop them down to the other atom. So it will become calcium with a subscript of 1 and chlorine with a subscript of 2. If there's any value of 1, you drop it, and if there's any common factors, they become reduced. So this just becomes CaCl2. We know that any compound ends in "ide", so we would name this calcium chloride. We'll look at some more examples and then I'll let you do some practice. Sodium oxide. Going back to your periodic table, sodium here, atomic number 11, first column, so it has a combining capacity of 1 plus. Oxide here, 2 negative. So we had sodium 1 plus and oxide 2 negative. We're going to drop these down, which will give me Na2O. Not going to write the 1 on the oxygen because I know I'm going to be taking it off. Aluminum chloride. If you look on your periodic table, aluminum's combining capacity is 3 plus. Chlorine's is 1 negative. So these drop down. AlCl3. For C through H, I would like you to do as an exercise. Pause this video now, take out your periodic table, and try to write the formula for these. Okay, I'm going to fill in the answers because you should have practiced this with your periodic table. So here to check, aluminum oxide becomes Al2O3. Calcium oxide becomes CaO. Magnesium bromide, MgBr2. Boron iodide, Bi3. Silicon oxide, SiO2. And potassium sulfide, K2S. Sometimes elements on the periodic table, sometimes the metals, have more than one possible combining capacity. And when they do, they are said to be multivalent. These are metal elements that have more than one ion charge. And they are said to be multivalent. When more than one charge is possible, you have to indicate which charge is being used. And we do this using a Roman numeral. So you are going to have to learn the Roman numerals, switch this back to a pen, for any situation you could encounter. So I'll just go through and list them here. The Roman numeral for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You will have to refer back to these often as we practice writing multivalent formula. For example, some examples of multivalent metals: chromium can be Cr2+ or Cr3+. To indicate a charge of 2, we would say chromium 2. To indicate 3, we would say chromium 3. Same with copper, using the Roman numerals to indicate the charge. We're going to do some practice working with this. So copper 1 oxide, this 1 means that we have an ion charge of 1, so that would have been copper 1+. Oxygen has an ion charge of 2 negative, so when we drop those down, you will get Cu2O. Pause the video now and practice B and C on your own. Okay, iron 2 chloride would be FeCl2, and lead 4 bromide would be PbO2. The last thing we're going to look at in today's lesson is writing the chemical formulas for multivalent compounds. The rules are that you have to insert an imaginary 1 where there's nothing. So let's pretend we had the formula FeCl2. We would insert a 1 at the Fe where there wasn't a subscript. Then you would cross over and up, so the 1 must have come from the chlorine. The 2 must have come from the iron. We check the combining capacity of the nonmetal. If it's wrong, then that means that we must have multiplied and then reduced. We must have reduced, so we would have to multiply. And then you would check the metal. If you have an option, you must use Roman numerals. So this means we have, let's just uncross this here, Fe2+ and Cl1 negative. We've got to check the chlorine. So we look at our periodic table. Chlorine's in this halogen family where they all have 1 negative, so it's correct. So we go back, and I don't have charges on my periodic table, but if you look at yours for iron, it can be 2+ or 3+. It must be iron 2+. We have to indicate that only when it's multivalent. So this would become iron, and let's see, I'm going to write this down here so there's space. Iron 2 chloride. I had to give the Roman numeral so we knew which iron ion it was. We're going to practice with the next few. Here, the 2 would go up to copper, the 1 would go up to bromine, and you would name this. You look on the periodic table, there is more than one possible charge for copper, so this would be copper 2 bromide. Next one, 4 goes up to tin, 1 goes up to chlorine, the 1 is right for chlorine, so this becomes tin 4 chloride. Pause the video now and try C and D on your own. Okay, looking at C, this would be lead 2 oxide. And scrolling down to D, this must have been lead 4 oxide. We're going to stop the video today here and learn about polyatomic ions next day.